here, the key word here, this could look literally identical in all sense of the word, that all you could change is that word there, and you'd have to do a completely different question. The group frequency diagram, the diagram is the important word, should tell you two things. Any ideas what they are? Bar chart, where the bars, good, bars touch on a bar chart. Okay, so it's a case now you just use a ruler, and from 0 to 5 you go up to 4, so you just need to work out your scales, so that should hopefully be reasonably straightforward. That goes up to 20, there are 10 little squares, so each little square is worth 2. So I'll just go up 2 squares there, across to 5, and then 6, so literally just up 1 bar, like that, and then 82, all the way up to here now. And then 76, so that would be 2 down from 80, and 32, so there's 30 halfway between 20 and 40, so 32 by here, and then just literally just draw the straight lines down. Okay, if it had been a frequency polygon, what would I have had to have drawn? Line graph, midpoints, good. Okay, so you just need to have those two definitions in your head. Over the page, scatter graph. Does anyone want me to go through this? No? Good. Part B, so this is also the scatter graph. Do you know how to calculate the mean of the y values? So it tells you what to do. So the x values, they just add them together and divide by however many there were. You need to do the same for the y's. Plot that point and just draw your line of best fit through it. Okay. Then was there something on this side? This one here looked pretty rank actually. Now my gut feeling is I don't think you're going to get asked anything like this. Any idea why? You did get asked the build question, didn't you, in your paper 1? So my gut feeling is we could spend 10 minutes on this. I don't think anything quite as similar is coming up, although it is going through slightly different ideas that we're calculating the volume of the room in meters cubed and stuff like that. It's up to you. What do you want to do? Not 100% positive. It's very, very unlikely that they won't come up again. Okay? It just seems silly from the exam board to test you repeatedly on the same thing. If you proved you could do it in the first one, what's the point in doing it again? Okay? Anyone want me to go through this? No? You happy for me to move on then? Okay. Again, this one here, is it worth going through that? Probably not. Do we have something quite similar come up with like octagons and stuff in our paper? Yeah? This one's never a bad one to do because they're quite straightforward and they're always worth 2 marks. Decrease 7,800 by 23%. 2 ways of doing it. Do 23%, so 23 out of 100 times by that. And then whatever that answer is, you do 7,800 take away. That answer will give you your final answer. Is there no quicker way to it? Yeah, very good. If you times by 0.77, if I'm decreasing something by 23%, that means I want to find 77% of the original because 77% add 23% equals 100%. And that way in particular is amazing for compound interest. It's much, much, much quicker because then you'd say find 77% of it, so you do 7,800 times by 0.77. And if it was happening over a number of years, you just do it to the power of whatever the number of years are. Ruth? 0.23 is the same as 23 over 100.
So could you do 2.123 times?
It's exactly the same thing that I've got here, okay? It's just written in a different way. Okay? Tom and Rita share 27 quid in the ratio 1:8. Again, pretty standard marks. Make sure you can get them. We'll do this in literally like 20 seconds. Add them together. Divide the amount of money by that. That's £3 for 1 share. So then for 1 share, it's going to be 3 quid times 1. And then for 8 shares, it's going to be 3 quid times 8. So my answer is going to be 3 to 24. Double check. Does that come to 27 quid? Does that mean I'm definitely right? It gives me a good indication if I am. If it's not 27 quid, I'm definitely wrong no matter what. But obviously 25 add 2 makes 27, so it's not definitely an indication that you're definitely right. But if it wasn't 27, you're definitely wrong. Our friend the nth term.
Do you reckon that'll come up?
Did it come up on the first paper?
There's a 9 marks altogether.
No. Trial and improvement. That didn't come up. We've done a bit of work on this as well. Hopefully we're pretty good at this now. Keywords
There's lines between.
and decimal place. That's what I wanted to hear. If I'm going to one decimal place, what am I really going to? 2. How many times do I go to 2 decimal places? Do I do loads and loads and loads of different answers? Literally once. Okay? So, set it up. Table. X equals x cubed minus x minus 10 equals 0. And then comment. Always try the 2 numbers given in the question, 2 and 3. As soon as I try 2 and 3, I pick up a mark. So 2 cubed minus 2 minus 10, that's going to be minus 4. And then 3 cubed minus 3, that's 10, that's going to be 14. So this one was too low, and this one was too high. That's what gets the marks going too low, then too high, because it shows it's in between 2 of them. So you might get asked to show why is the solution of this between 2 and 3. So well, here it's too low, here it's too high. So it must be in the middle of those 2 numbers. From there, are we going to go 2.5? I wouldn't. It's my gut feeling. Any idea why? Lewis?
I'm going to go further with this closest.
I'm going to go to one that's closest to 0. This one's closest to 0, so instead of going 2.5, which is bang in the middle, I'm going to say like 2.2, just because that is a fair bit closer than 2.4 is. It may be that has absolutely no resemblance at all in the answer. Maybe I'll have to end up doing a load of extra work anyway. But if you go 2.5, it's what you call your sort of default method. If you're there thinking, I don't know what he's talking about, just go to 2.5 and then work your way. But go in consecutive numbers, don't miss out any numbers when you go to 1DP. Because if you miss them and it goes too low and too high, that's the end of your marks. You'll lose a load of marks potentially. Okay, so 2.2, I can't do this one in my head. Can you help me out? 2.2 cubed minus 2 lots of 2.2 minus 10. Don't all help at once, whatever you do.
Minus 1.552.
So why
Minus
have you done-
1.552. Go on, say
Why have
again.
you done minus 2 times 2.2?
I'm just changing the x to open brackets and then
Times
cubes
2.2.
there. Ah, I got overexcited. Okay, so there's no need to do minus 2 there. Hi guys, selling poppies. Anyone want to buy a poppy? Anyone got some money? for that?
Any money for a poppy?
Yeah?
Pound for a restaurant.
Sorry, Kellen. Was that minus 1.552? Is that down to my fault from having 2 that before? That's the correct answer anyway. Okay, so that's too low, so I'm going to go to 2.3. So then 2.3 cubed minus 2.3 minus 10. I'm guessing that's probably going to be a positive, but I might be wrong. Minus, thank you, 0.1 blah blah blah. So that's still too low because it's minus, so it's 2.4. So I haven't actually saved a huge amount of work by doing that, but sometimes it can do. So then 2.4 cubed, so I'm pretty sure this is going to be positive. 1.4, and that's too high. Now, that's where I get my mark, where it goes, so they'll be checking this, they'll be saying, does it go too low, too high? It does. Are these consecutive numbers? Is that one number after another? Yes, it is. So that's how I get that second mark. So this was my first mark, doing the numbers they said, that's my second mark. If I now look at that and say, look, that answer is clearly closer to 0 than that answer, so x equals 2.3 to 1 decimal place, no more marks. Paul?
Do you need to write out the equation each time, or can you just write the answer?
When you're doing it in class with me, if we did loads, I'd say, look, it's fine, skip it. Tomorrow in the exam, just jump through the hoops. Okay? It is a lot of work to write out, but it is 4 marks, and part of those 4 marks, so it is time consuming. Just write it out, okay? It's not like it's taking me loads of effort to write that out. Okay? So, I'm going to go in between 2.3 and 2.4, so that's 2.35. That's then going to 2DP, but like I said, once, that's it. I don't go to like 2.37 or whatever next, that's it. Okay? As soon as I do that as well, I get, as long as I subbed into my formula and stuff, I get my next mark. Okay? And once I've got that third mark, then I can be awarded that. Even if I wrote that one down first, I could have still got that mark. Okay? So that is, I'm guessing it's positive 0.62, which is too high. And then I can get that mark there. Okay? So pretty pretty easy ones, just jump through the hoops. Oh, this one came up recently in the other lesson, didn't it? Distance between Lancaster and Glasgow is 170 miles when travelling by road. It has a scale of 1 to 500,000. 1 centimetre represents 500,000 centimetres. Use this information to calculate the distance by road. Give your answer in centimetres. Okay, so they've got miles there and then centimetres there, so I have to have them in the same unit of measure. But it's even a bit more mean than that because miles and centimetres is metric to imperial, so you need to know a conversion here. Any idea what it is, Grant? Good. So how many miles equals how many kilometres? 1 mile equals 1.6 kilometres, very true. Or I tend to use this one myself, just because it's like maybe a little bit easier to remember because they're both whole numbers, but it's fine. Whichever one will do the trick here. Okay. So we need to change this 170 miles into kilometres. Then we have it all in the metric system. Then we need to change that into centimetres and then work out the scale. We good? Okay. So 170 miles is equal to how many kilometres? Actually, we've got two options here. I can either say how many 5s go into 170 by dividing by 5, or I can just say you times your miles by 1.6. Which one do you want to do? Times by 1.6, probably quicker. Someone help me out. 272. So it's 272 kilometres. Let me see what I'm writing here. Which is 272,000 metres, which is 272,000. How many centimetres in a metre? 100 cent, meaning 100. So I add on another 2 zeros, would be that in centimetres. So that is, if I go and put my commas in now, 1, 2, 3, 1, 2, 3. It's 27,200,000 centimetres, which is why we don't measure the distance to different cities in centimetres. It'd be rather silly, wouldn't it? Okay, so the scale is 1 to 500,000. So if I know 1 centimetre is equal to 500,000 centimetres, I've effectively got 27,200,000 centimetres. Any idea what I'm going to do next? Do that one divided by that one, and it will tell me how many times multiplied it by, okay? How much is it? 54.4? All good, are we happy with that? Yeah, whatever I do to one side, do to the other side. So just reference to how we got that, it was 27,200,000 divided by that one there, that's how we worked that one out. So 54.4 centimetres. Sounds rather large. Are we all happy with that? Is that definitely the case? Alright, take your word. And then finally what we've got here. Fuel consumption on Gwen's car depended. This is true, did you know that? In terms of if I want to make something travel twice as fast, you don't put in twice as much energy because like you've got loads of forces acting on it, like wind resistance, air resistance, and so on and so on and so on. So to make something go twice as fast, it's not a case that you just have twice as much energy. So if I drive at 10 miles an hour faster, it's going to affect my miles to the gallon. So people who are like economical just try and drive a bit slower. So when you're like 17, you pass your driving test, then you go and fill up petrol and you realise it lasts about 5 seconds if you drive like an idiot. You just drive a bit slower and it'll be fine. Okay, so what we asked to do, so we've got these two different average fuel consumptions. Fuel costs 1.56 a litre. It's a bit cheaper at the moment. It did get up to around that in diesel. A litre is approximately equal to 0.219 gallons. She drives 170 miles. Calculate the savings she could make. So we need to do it once when she's driving at 60 and once when she's driving at 50. Okay, so organise your work carefully. I do 50 miles per hour by here, and then I just draw a line down and do 60 by the side. Okay, so when she's driving at 50 miles per hour, she's getting 44 miles per gallon. Miles per gallon. Okay, so what am I going to do next? What do we think we should do?
70.
Go on then. 170 divided by 44. What will that work out then, Gran?
The number of gallons.
Fantastic, well done. It's weird, isn't it, having all these numbers trying to work out what that's actually telling me. So the distance divided by the MPG will tell me how many gallons were used. So 170 divided by 44. Help me out.
320.
3.86. Is that rounded or is that just what it is? Okay, so we're going to leave that in our calculator as the answer button. Yeah? So we've used that many gallons of fuel, so how many litres have I used? So, excellent, you are going to divide it by 0.219. How do I change gallons to litres? So you can't see quite what I'm doing here, can you? Well, to change litres to gallons are times. To change gallons to litres are divide by that number, by 0.219. So I need to do this one here, 3.86, or that answer before, divided by 0.219. And that will tell me how many litres I've used. How many?
17.64.
17.64. And then how much is the price of fuel?
Times about 1.5.
Excellent. You times that by 1.56, and that will tell you the cost pounds. 27.15. 15. 15.
No.
50.
5.
5. Sorry. To 2dp. Okay. It's a little bit easier sort of question like that for me because I know roughly how much it would cost if I drove 170 miles. The hardest bit for me for you to get was probably that bit there, 3.86, and it was divided. Did anyone do times there? Quite understandable if you did. The way that I remember it is you have more litres going to a gallon. So have you ever seen in films like how much the price, you don't really notice it at your age, you notice it when you're my age, when you're sad, and you look at how much the price of fuel is in other countries. If you see a film in America, you go, ooh, that's a lot of money, or that's really, really cheap. Lewis?
You know, with the answer there,
Yeah.
it comes up on the calculator as like 27.5 recurring.
27.5 recurring.
Yeah, so.
Now that, to be fair, they're probably going to accept like a range of answers there, not like a massive range, but within sort of 20 pence of each other, maybe within about 10 pence of each other. That sounds fine to me. It sounds like you're doing all the right things. It sounds like you probably kept your answer the whole way throughout. That sounds good. Okay, so I'd be quite happy with that answer. So for 60 miles per hour, pretty much the same rationale going throughout. So 38 mpg. So then it's going to be 170 divided by 38 this time. That'll equal so many gallons. Okay, and then once you've got that answer, you'll divide that by 0.219. That will tell you how many litres it is. Then you'll times that by 1.56, and it should be more money. Hence, it makes better financial sense to drive. Not only to do that, it reduces carbon emissions, so you can feel better about yourself for not wasting so much carbon dioxide.
What's that L and what's that 1?
L here,
Yeah.
litres.
So 1.56.
1.56 is the price in money for the price of fuel, price per litre.
I've got
So
31.87.
31.
That sounds good to me. 31 quid, point
87.
87. Sounds good. So she has saved how much? 435. It's be 437 by my working, I think, isn't it? Okay, like I said, there will be a little bit of leniency. There's an awful lot of numbers you could have rounded there, and although they are stingy on it, and you should use the answer the whole time, they do give you a little bit of leeway. Okay? So just by dropping off 10 miles an hour, save enough for a McDonald's on the way. Oh, perfect.
So if you like drove at 30 miles per hour, you'd like to
Yeah, if you drive at 30, you would save loads of money, but you can't drive on the motorway at 30. It's illegal.
Is it? Oh,
Yeah.
sorry.
You drive on the motorway at 70. If someone's driving at like 50 on the motorway, it's really, really, really dangerous because you go on, you're expecting everyone to be doing 70. Obviously, some vehicles are limited, like big lorries are actually limited at like 60 miles an hour, so they can't be going too fast. The more faster they're travelling, more damage they can do.
I'll just drive behind a lorry.
Well, if you drive behind a lorry, don't get too close, but it will break out all the wind, so it'd save you even more money.
I'll be going behind a lorry.
There's Let's see if I can find it actually.